Turn the lights back on. Wow. Retro electro tech. When real audio ruled the world.
Greetings, ladies and gentlemen. Grüße, meine Damen und Herren.
Grüße Retro Ernst.
This is Retro Ernest of Retro Electro Tech, and today I'm performing in part another quick and dirty evaluation and some pre-restoration preparation on this Audire Crescendo 75 watt per channel stereo amplifier. So anyway, I'll be doing a spurt of these quicker evaluation and restoration prep videos as I get several amps and receivers positioned on a few different benches throughout the shop so that I can of course get them on their way to completion and out the door. So first things first, let's look at the condition under the hood and take note of our observations. So let's go ahead and get to that. Now the first thing that stood out was the hood itself and these big old Mongo Chongo screws someone used in place of the originals. So what's the big deal, right? They hold the cover on, one might say. Good enough. Well, it's obviously the first big indicator that someone's been in here, and that mindset of any old screws will do that may just set the precedent for what awaits us next. So as you can see here, and I'm going to spin this around and just kind of zoom down in here, this is the first thing here that greeted me from within this amp. As you can see, the amp channel wiring is disconnected from the power supply board here. So that being the case, there's a few possibilities to consider. The first and most obvious is what's going on with this channel. Why is it disconnected from the power supply board? You know, are there shorted transistors or something else going on that's rendered this channel bad? Another possibility may involve good intentions, believe it or not. And what I mean is the connections between the power board here and the amp channels involve these male spade terminals and their female counterparts that originally connected to the wiring here that I found disconnected. And if you're not familiar with what the female connectors look like, these are them right here. Most of you know that, and you know, I'm sure they ring a bell because they're very common connectors which slide onto the male spade ends here. Not my first choice, of course, in achieving a bomb-proof connection or connectivity, and I'm not going to go into a lot of details as to why that is, and I'm not saying either that good connectivity can't be achieved with such connectors and a variety of others as well, but there's some factors to consider that I'm going to mention, just a few. Number one, the quality of the connector. Were these connectors produced with good metal, or are they the cheaper overseas version? Remember, oftentimes people are servicing this equipment, there's hands in here, they're pulling connectors apart, plugging them back together, so forth and so on. And if the connectors are cheap to begin with, if cheap metal is utilized in the production of these connectors, then you know they can very easily become loose. So there's that part of the equation. Also, to environmental considerations with just connectors and pins and so forth in general. In areas or parts of the country or parts of the world like this where we have higher levels of humidity, damp basements that people often store their equipment in over the years or whatever the case, I see a lot of oxidized, tarnished connections, pins, this, that, and even surface rust on connectors. So that's another thing. And ultimately, nothing beats a well executed solder joint. That's the bottom line. I prefer to go straight to the board. And I think that, or at least it looks like, the individual who was in here was trying to solder straight to the you know, these male spade connectors, perhaps to achieve a more solid connection, but just did a really, really bad job. And I'm going to get a little bit more into that, but I wouldn't have even tried to solder to these spade connectors unless I absolutely had to. And because of the size of the wires, you know, the holes here should have been opened up a little bit at the very least, but I would have desoldered these from the board and just went straight to the board. Okay, and I'll get more into that in a bit. But anyways, I'm going to zoom in a bit and reveal a few more details before moving on to a safe power-up attempt. And I'm going to leave this channel disconnected during that time because again, I don't know exactly why the individual left this channel disconnected. He was able to achieve connectivity. He was able to solder onto these terminals over here on this side, and these wires actually feel like they're intact. They feel secure enough. So being that this channel is connected to the board, when I power up, I'm going to, you know, just go ahead and leave this channel as is, and but leave this one disconnected just in case there's something wicked going on here with, you know, some shorted components or whatever the case. So again, let me go ahead and move forward. Okay, so a few things that I wanted to point out here. I wanted to zoom in a little bit and show you the soldering that this individual was trying to achieve on these terminals. And you can tell this person was having a really hard time with getting these wires soldered to the spade terminals here. And there's a few reasons why that is, and I'm going to kind of break it down a little bit. But number one, these are some big wires, okay? And you can see how, you could just see how nasty the you know, the soldering is on the wiring here. It's all chunky and just the individual was not achieving enough heat. You can tell that right off the bat. And that's why everything is so bad, even on the terminals. You can just see how dirty everything is. And let me kind of get into that. Also too, I'm concerned about what awaits me on these boards here as far as damaged pads and maybe even traces and all that, because this person had to really camp out on the solder joint to get these things to take somewhat, and they didn't take very well. You can see up here just how loose this wire is. On the other side of the board, I can tell you right now that the solder joint is loose. It's broken free, and look at how look at how loose this one is here, and up here. And I'm gonna get into this wire a little bit more, but this one is just, I mean, you could see just how horribly loose that is.
Wow.
So this individual didn't have the soldering skills or the right equipment to achieve what needed to be done here. And it's worth mentioning from this point of view what an individual with perhaps little soldering experience and maybe an underrated or, you know, cheap soldering iron or station, whatever, would have been going through trying to achieve, you know, bomb-proof solder joints in this situation, using larger wire, dealing with larger terminals that are in turn attached to large surface area traces, okay? And that combination is going to pull a lot of heat from a soldering iron right off the bat once you drop the tip onto that surface, and you're going to want a soldering setup that can deliver the heat, deliver it fast, recover fast, to be able to melt that solder right onto the to the terminal and achieve that wetting action, okay? I'm going to briefly touch on this big, you know, black piece of junk wire a little bit more, and I pointed it out a moment ago. This is the wire that's all dangling around. It's detached from the pad on the back of the board here between the heat sink. You can see it all dangling around. So anyways, it looks like what happened was somebody carried this wire directly over to the one half of the indicator board here, and I'll get into that just a little bit more in a moment, instead of going from the pad, from the solder joint straight to the spade terminal here, as is the case on this channel here, and I'll get into that again in just a moment. But had they have done that like they should have, and again, this black wiring all in here and all that isn't the original wiring. Whoever was in here messing around, and I don't know when they did it, or I know nothing of the history of this Crescendo amp, but anyways, this should have terminated here on this spade connector, and there's a trace that runs along the top of this power board here up to about here. Yeah, there's a pad right about here, and there would have been another wire that carried signal over to, again, this one half of the indicator board. But they decided to go straight into the board, and I will talk about the consequences of doing that. And why they felt they had to bypass the trace, I really don't know, because it looks to me like it's intact. And real quick, a matter of fact, let me grab my meter and check continuity from this terminal here, spade terminal, to the pad over here. And as you can see, the trace is intact. So why they felt the need to go directly to the board is a mystery. And as you can see, if I flip it around here, and we look at let me go ahead and zoom in on things a little bit more. And again, if we look at the opposite channel over here, you can see the same setup here. We have our wire leaving the board here in the same spot, and terminating here at this spade terminal, and via this top trace here, signal is carried across to these wires here, and it feeds this other side of the board. At least that's how everything looks. It looks pretty self-explanatory. And what this board is, real quick, it's an indicator board. You have your two green LEDs here that are power indicator LEDs that show that there's power to both channels. And then you have a red LED here, and you have one missing over here, no surprise. And these are clipping indicator LEDs, so obviously when the amp is going into clipping, these light up. Now you can see here this big, let me see, I don't want to zoom in too close, but you can see this big monstrosity of a burn mark here, and they went, like I said, they went directly to this board with this wire. It looks like they expanded the hole, shoved this through, and they were camping out on this solder joint forever and a day and burned things up trying to achieve a connection. So, and as I just explained, that shouldn't have been done. So it is what it is, though. It's done now, so I'm going to have to go in there and repair things. One more thing I want to point out real quick that I almost forgot about is the fact that you notice here that if you look at the section of wire here that's detached from the pad there between the heatsink and the board here, you'll see a white wire that meets up with, at least I think you can see that white wire down there. It meets up with that same solder joint. It looks like they use that wire as a jumper to bypass maybe a damaged trace. That's what I'm thinking. When I pull the board off, I will I'll know a little bit more there. But the reason I'm concluding that, because over on this side over here, again, same exact setup. There's no additional wire that's feeding that solder joint. That's yeah. So, anyways, but what there is a trace, obviously, that meets up with that pad, and it's all intact on this side. I can't really see down here if there's a trace because, again, there's that white wire that's in the way. But I don't see any other reason why they would have done that unless during the during the time when you know, they were camping out on that you know, on that joint there, they probably burned up, you know, the trace, screwed it all up or whatever, and had to bypass it. But that's what I'm thinking at this point. So I just wanted to touch on that real quick, and you know, let's go ahead and move on to the power supply and go from there. So real quick, here we are at our illustrious power supply section, the heartbeat of it all, right? And here we have our two 32,000 mic 60 volt electrolytics, our main filters, reservoir caps. Over here we have this nice beefy power transformer. Under here we have a full wave bridge rectifier. Here we have two, there's one tucked down here, 8 mic 200 volt film caps that are positioned in parallel to the main filters. I was looking to see whether or not other specimens online utilize these bypassing film caps here butted up against the main filters here. I'm not an Audire-ologist. I know there were some different versions of this Crescendo amp, and I didn't suspect that these were installed by the manufacturer, but I was just wondering you know, if other specimens utilize these, if people were having issues with oscillation or whatever the case. Typically when you know, these bypassing film caps are used, you know, it's for the purpose, as some of you know, to you know, reduce high frequency noise, or for high frequency noise suppression, in other words. And also too, some of you know that usually this is not a good choice as far as position is concerned, to just butt these film caps, you know, up against the you know, main filters. These are usually better served when they're positioned strategically closer to the load, or, you know, active devices and all that, and, you know, with the objective of providing a high frequency, low impedance path back to the power supply, and in turn, you know, reduce, you know, big, you know, gnarly loop areas to achieve that end of, you know, reducing high frequency noise content. Now, I'm certainly no engineer, just a lowly repairman, but in principle, when it comes to bypassing and decoupling, what I just mentioned seems to be the case in most situations. Nonetheless, though, I'm going to leave these caps in place for now while I power up this amp. So let's now turn our attention to the current limiter, also known as the dim bulb tester. Okay, so we even have our petrified resident spider entombed within the catacombs of this unit. So I'll point him out here if you can't see him right there. So let's go ahead and do a spider extraction here. Oh, got him. All right. Here's a little pet spider for you, Retrobot. No, come on, Retrobot. Don't be a little sissy girl. Okay, so here's our current limiter here. Let me actually zoom in here. And I briefly talked about this piece of equipment, safety equipment before, and when it comes to initial power up of anything, and just keeping a clamp, if you will, on the supply of current to the device under test, this is what I use all the time. Of course, you know, I don't want to ever plug a piece of equipment directly into an AC receptacle when I have no idea what's going on with it. I don't know its history and all that. I mean, for example, look at the you know, amp we were just going through, and all of the you know, hackery in there and bad soldering and all that. So I want to incrementally be able to provide or meter out a safe amount of current in an effort to avoid a big nasty failure, which in turn will result in, you know, more damage than the equipment came in with. Now, the amount of current limiting is determined by the size of the bulb in terms of wattage that we end up switching in. So you can see over here, well, I've got these 3 switches you see over on the side, and you may be able to see these markings here, 40, 60, and 100, which correspond to the bulb wattages in this current limiter. And in keeping things short, the 40 watt bulb, for example, provides more current limiting than the 100 watt bulb. So a tech has to decide what size bulb to switch in based on the normal current draw of the device under test. The point being is that if you have a beast of an amp on your bench, for example, and you switch in that 40 watt bulb, then it's going to glow pretty bright, which would make it a little more difficult to distinguish whether or not there's an issue going on. And additionally, the stiffer current limiting is going to impede circuit functions that you might not want impeded, like a protection relay kicking in, for example. What you're going to typically see if you have an appropriately sized bulb switched in, and of course if there is no faults or issues causing excessive current draw, is the bulb is going to initially increase in brightness as the large main filter / reservoir caps experience that inrush of current and charge up. Afterwards, the bulb should level off to a very dim glow, hence the term dim bulb tester. Okay, let's get the amp powered up, and I'm going to actually go ahead and start with that 40 watt bulb for demonstration. And notice when I kick it on, notice the initial inrush and the resulting brightness, and then it's going to level off. Now, if it, you never know with this amp, considering the condition it's in, but if there is a fault or some problem, then it's just going to, it's just going to illuminate, and it's going to stay that way. It's going to be really bright. And anyways, let me go ahead and kick it on. By the way, that amp channel that is disconnected, I'm not reconnecting it right now. I'm just going to start with the amp channel that is currently connected to the power board and go from there and see what kind of result we get. So here we go. Keep your eye on the small bulb over there, and go from there. Okay, and you see that it leveled off. Let me turn this light off real quick. And you can see the intensity that it's glowing at now. Okay, so that's good that we're not getting any any bright glow to that bulb, and it might even look a little bit brighter on camera, but anyways, it doesn't look like we have a fault situation or anything drawing heavy current, and especially with that 40 watt bulb, if there was some excessive current draw, we'd really see it with that bulb. It would illuminate quite brightly. So anyways, let me go ahead and shut this off again, and then I'll be back in just a second. I'm going to discharge these caps here. Okay, let's get these discharged here. Okay, and you can see we're drained off to what, a couple hundred millivolts. So let's go ahead and move forward here. Okay, now that the caps are all drained off, let's power the amp up again. This time we're going to use the 60 watt bulb, and notice the difference in intensity as well as the glow of the bulb. So let's go ahead and do this. Okay, and let's go ahead and get this light off again. Okay, again, sometimes the camera will exaggerate the illumination. Nonetheless, on my end over here, the glow of the bulb is decreased from the glow of the 40 watt bulb. So let's go ahead and drain the caps off again, and then we'll try it with the 100 watt bulb. Okay, now for the 100 watt bulb, notice the difference in illumination. It might be hard to see it with the camera, but I think you'll get the point. Okay, and let me kick off these lights here. That bulb, you can barely see a little bit of a glow from it. So anyways, there you go. That's kind of the point that I wanted to convey as far as your different bulb wattages and current limiting and what have you, based on you know, the size of the receiver or the amp that you have under test. So anyways, let's go ahead and move forward. Okay, so I've had the amp powered up for a bit now with the 60 watt bulb switched in on the dim bulb tester. Everything's looking good. Again, as we witnessed, no dead shorting, no excessive current draw, no bulbs lighting up bright enough to give us a suntan, so we're looking good. You know, we have no way of knowing if everything's going to remain the same or if, you know, something's going to try to fail on this amp, considering the condition it's in. But again, you know, there's that old saying, don't judge a book by the cover, because even a piece of equipment that looks very clean, because of the age of all of this vintage gear and not always knowing its history, who's been in there, what's been done, and all that, we never know if we're going to experience a fault, which is the reason why we use the protection of such things as current limiters, and sometimes bringing things up slowly on the variac, sometimes using a variac in combination with a current limiter. And that's all stuff, if you want to know more about it, look it up. There's so much information out there nowadays with the internet and all that. I'm sure there's a bunch of stuff on that topic, but this was really intended just to cover the core fundamentals, okay? Because it's really hard to cover everything in one video. I've brought that up before, and then there's, you know, different strokes for different folks. What might turn out to be useful information for one is not for the other. And I don't have very many followers on this channel, but if I did, I would certainly anticipate a lot more questions and all that. But I'm sure I wouldn't be able to answer them all to you know, satisfactory standards for everybody, because again, it's just hard to cover everything. So the bottom line is that everything is looking okay right now with the amp powered up on the current limiter. And I'm looking up at the 60 watt bulb now. It's still glowing very dimly, so that's good. Let's hope it stays that way. Like I said, once again, I'm not hooking up this channel, you know, because of the condition of the wires. You remember I was jiggling them all around, and until I get the this amp board pulled from the heatsink here and have an opportunity to take a look at the soldering on the back of the board, the condition of the traces and all that, you know, looking for obvious signs of imminent failure and shorting and all that. I don't even want to take a chance with this. I'm not going to deal with this right now. But because this channel is intact and, you know, the wiring isn't loose and, you know, this guy's solder joints are holding so far. And again, we powered it up just a moment ago and we didn't have any dead shorting, excessive current draw. Obviously, this channel's not doing anything horrendous. So what I have going on is I have the meter, the probes there, hooked up to the output of this channel. And let's just see what our DC offset is looking like. So let me go ahead and get this on here. And let me pan on down to the meter there. And it's bouncing around between 790 something, 800 and something. So it's up there a bit. No surprise. You know, this amp is going to need a lot of TLC, and obviously I'm going to go through and, you know, recap, you know, check the tolerances of all the resistors, check transistors, you know, so forth and so on, and just clean up everything. And you know, I'm going to be analyzing the amp channels, injecting signals, looking at waveforms, and you know, measuring voltages. I'm going to check where all the voltages are sitting, and just you know, the biasing and all that stuff. So I've got my work cut out for me. There's a lot of cleanup to do to get this thing, you know, where it should be. Also, too, I'm going to be replacing the big filters here and the whole 9 yards. So, anyways, what I'm going to do now is get a signal into the input and just kind of see what we're dealing with in terms of amplification. Is this channel amplifying? So let me go ahead and do that, and I will switch right back in a moment. And coming from the generator, we have our infamous 1 kilohertz tone feeding into our channel here, and lo and behold, we have you know, we have amplification. Okay, so not bad, not bad. We are getting some amplification, and okay, we're starting to clip there. Okay, so anyways, that's all I'm going to do this go around, because again, I don't want to leave this amp powered up too long until I check it over a little bit better. Again, get these channels pulled, boards pulled off, you know, do what I got to do. So thanks for following along, guys, and anyways, as I always say, peace, love,
music, 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 music.